These are the solutions to the quiz at the end of lesson 8.1. Now, number 1, Galileo attempts to measure the speed of light. Now, we know that speed is always distance over time for a constant speed, so time is going to be distance over speed. Distance 1,500 metres, speed 3 by 10 to the 8 gives us 5 by 10 to the minus 6 seconds, or 5 microseconds, so that is C. Now number 2 is D, because some objects give out light, they are luminous, but some just scatter it. 3, if we have a look at the options, A and B actually have reflection in them. C says no light is refracted, which means that all of it must have been reflected. D, not all refracted, means that some must have been reflected, so E is the only possibility there. And number 4, that is A, because only A involves white light spreading into its different wavelengths. Now, question 5. We have a pulse of laser light, and the first thing they want to know is how many wavelengths in one pulse. So we know the frequency of the light, and that is 5.1 by 10 to the 14 Hertz. So the wavelength, and I'll call this the wavelength in air, is going to be speed of light over the frequency is 3 by 10 to the 8 over 5.1 by 10 to the 14, and that gives 588 nanometers. Now, the pulse is going to be like this. So it is on for an interval of time, and that interval is 2.7 by 10 to the minus 11 seconds. And we want to know essentially how far is the light going in that time. So we use the equation for a constant speed. The distance it goes is the speed times the time, which is 3 by 10 to the 8 times 2.7 by 10 to the minus 11, and that is 0.0081 meters. So the number is going to be this distance divided by the distance for one wavelength is going to be 13776 wavelengths. Now part B, the refractive index, simply defined as the speed of light in a vacuum over the speed in the water. 3 by 10 to the 8 over 2.3 by 10 to the 8 gives us 1.304. And we'll call that 1.3, but now we want the new wavelength in the water. So the wavelength in the water over the wavelength in the air is going to go in the same ratio as the speed in the water over the speed in air, which is C, and that is 1 over n. So the wavelength in the water is 1 over 1.304 times 588, and that means it has gone down to 451 nanometers. And now the new number is that same distance over the new wavelength by 10 to the minus 9, and that will mean 17960. Now number 6, sine of the critical angle is n2 over n1, 1 over 1.8, which is 0.555, so the critical angle is 33.75 degrees. And remember, we don't turn it into minutes and seconds because we want everything to be a decimal. Now number 7, let's start with the red light. sine of the refracted angle for red is N1 over the refractive index for red times sine theta 1, which is 1 times sine 45 over 1.520. So the angle for red is 27.7233 degrees. Violet, we have the sine theta for violet is 1 times sine 45 over 1.538. So that means the angle for violet is 27.3714 degrees. I've kept so many decimal places so that I can then subtract them. Going to be 0.35 degrees.